All right, so now that you have checked your answers on the prisms and cylinders portion, let's move on to the volume of pyramids and cones. So we are talking about the volume of a pyramid. It gives it to you right here already. Big V is equal to 1/3. Big B, there's that big B again, times H, where B is the area of the base and H is the height of the pyramid. Height and base form right angles. So we call this a right pyramid. And yeah, like it or not, we're getting get back into Pythagorean theorem quite often to determine what's going on. Let's just go back to our formula sheet real quick. Make sure you know what I'm talking about. The pyramid's located over here on the right-hand side on the bottom, and the volume formula is right there at the top. V is equal to 1/3 big B times H. They give you the H, they give you the big B. They do their best to try to explain that. This other dimension is going to come into play when we get into surface area. For now, all we care about is the height, which is the distance. Right, just to make sure we all see what's going on here. It is the height from the base all the way to the top of the pyramid. And then the big B, of course, is the area of the base. So let's go back to the notes. You guys have that. Y'all have those in front of yourselves or in front of you. Whoops. All right. So again, I like to do this every single time. The volume is equal to 1/3 big B times H. That way I've got my safety net. And then I'm going to make a little list of things that I know. What is the known information given to me? I have, let's see here, a dimension of 6 and a dimension of 6. And that's telling me that my base is actually a square. So maybe I write down something like square base. And I've got a side that's worth 6. And so that's helpful because I know I have a formula for area about squares. I also have some interesting information. They've given me a right triangle that's formed. And let's highlight that. So if you have your highlighter, you may want to highlight that. They've told me that this 5M is representing the hypotenuse of that triangle. I need a height of the pyramid. They did not give that to me, but they do give me what looks like the hypotenuse of a triangle where the height is part of that triangle. The dimension down here on the bottom is 3. Since this middle point is right in the center, I know that this bottom portion from the one side of the pyramid, okay, to where it would hit in the middle is going to be half the length of one of the sides of the base. So I've got myself enough information to come up with the height. So I got 2 things I need to worry about. I don't even know how to explain this in terms of the known information, but we know we've got a square base. We know our sides are worth 6. I've got a triangle that's going to help me determine what the height of the pyramid is. So we're going to do that first. Let's get that straight. We're going to use Pythagorean theorem to solve for the height. So I'm going to kind of do that over here, where I'm going to use 5 squared is equal to 3 squared plus h squared. Okay, so we're just using Pythagorean theorem to come up with what's missing. And when I do that math, h is equal to 4. So this is one of those kind of tricky situations where they've given us a right triangle on the inside. We need to apply Pythagorean to come up with the dimension we need. So that gets us that. We also need the area of the base. Well, I've got an area formula. I'm going to go back to my formula sheet. The area of my square is right here. It's equal to s times s, or side times side. It plays the same kind of role as the area of a rectangle, length times width. If you consider this the length and this the width, the same process would be in play, right? So hopefully we've seen this somewhere in our math lives before. I'm going to go back to my notes now. And I'm going to know that B is equal to the area of the square. So I'll just put that subscript as S. That's equal to S squared, where S is equal to 6. And so the base area is 36. And since we're in meters, it'd be meters squared. By the way, this height was in meters. So unit of measurements are not overwhelmingly important. They're not going to try to trip you up by giving you like centimeters versus meters or making you do switches between those or anything. But it's still important to maybe understand that area is in square inches or square meters and so forth. So we've got everything we need. And I'm going to geek out again and rewrite that formula above just to make sure I know what I'm talking about. The volume is equal to 1/3 times big B times h, which is the height of the prism, or I'm sorry, the height of the pyramid. So we're using 1/3, where big B we decided was the area of the square, which we found to be 36. And then the height of the prism, we used a right triangle to determine that was 4. So doing the math, I come up with 48, and we are in meters cubed or cubic meters. Whew. So this is probably as deep as it's going to get. You will see, just re-highlight this, you will see triangles like this form inside our 3D figures. We really would have to think out of the box to determine, or out of the pyramid, to determine what we need in order to get to the right information. All right, our cone. After our cone, we got the sphere, and we are done. The volume of a cone, they give it to us here, but of course it is on the formula sheet, is equal to 1/3 pi r squared h. And guys, remember, pi r squared is the area of any circle, and you can see the base of the cone is a circle. So the same thing is kind of happening here. Area of the base, pi r squared, times the height of the cone. All right, so rewriting this, 1/3 pi r squared h, where r is the radius of the base. Can look here, notice we've got ourselves this dimension from the center, right? We've got the radius, so they've given us what we need there. And then the distance from the top of the cone to the base is considered the height. Now, if we were really feeling froggy, we could even figure out what this dimension is, and that will become important to us when we get into surface area next lesson. All right, we have everything we need. So this is kind of a no-brainer. I'm going to just reapply the information. 1/3 pi r, which is 2h, r squared, which is 2 squared, times h, which is 7. And when you do the math here, you get 29.3. And we're in miles this time, so miles cubed. So this, of course, could be in terms of pi, where we kind of just leave the pi alone and multiply all the rest of the items together in order to determine what we would call it in terms of pi. But honestly, I don't think this is going to be very pretty, which is probably why I haven't even calculated it yet. But 1/3 times 4 times 7, since 2 squared is 4. And yeah, you end up with just an ugly decimal, which is like 9.3 pi. And generally speaking, they wouldn't give it to you like this. At that point, you got a decimal times a decimal. Like, why bother? So more often than not, you would see it in this way as a just to the 10th place and move on from there. All right, let's move on to our sphere real quick. And then you guys can do the same thing you did on the prism by doing the problems on the bottom. We're just going to swing down there. You do have some things going on here where you have a cylinder that you're going to use, right? So you'll end up finding the volume of both the cylinder and the volume of the cone that's on top of that container. So you'll use those dimensions separately. It looks something like this. We used to do this back in the 8th grade, I think, composite figures. The volume of the cone plus the volume of the cylinder is equal to the volume of the container. So be careful. You can't just use one formula there. You do have two that you're going to need to use. The others are problems that give you enough information to determine what you need to grab from the formula sheet. And you just want to rewrite that formula next to the problem and substitute the values when you get there. All right, let's move on to the sphere, because this will only take a minute. Our sphere, fortunately on the formula sheet, it says volume of sphere / hemisphere. If I go back to the formula sheet, it is showing two formulas, one of which is the volume, which is equal to 4/3 pi r cubed. And so we're going to take that and use it here. In fact, they've rewritten it for you there. We've got the volume of a hemisphere that's noted here as 0.5 times the volume of the sphere. If I were to slice this sphere into 2 equal pieces, and whatever the volume was that I started with, I would have half of the volume. So the formula sheet doesn't give us the formula for the volume of the hemisphere, similar to what we've been managing for our sector and length. It just gives us the volume of the entire sphere. But we know it's going to be half as much if it's a hemisphere, and that's really the takeaway in terms of what the term means and how it's going to play out. So we also have some problems here. In number 1, I don't know where the 2 is on this one. This is number 2. In number 1, we pretty much have the dimensions we need. The big takeaway that people make mistakes on for the volume of any sphere is the fact that you need to use a cube situation. So 4/3 pi r cubed. And students kind of forget where that is because we don't use it that often. In this example, we've got a radius, so an r equal to 3.5. So this one's not that big a deal. 4/3 pi, and we do 3.5 cubed. So what do we do for our calculator? I'm going to do 4 divided by 3, multiply it by pi. So I've got some parentheses. In fact, let me show those parentheses here. And then in parentheses, I'm going to do 3.5. And the easiest way to do this is to hit the caret button, which is the same button that got you the pi, and put a 3 there. You need a right click or a right arrow over so you can get out and put your final parenthesis in on the end. And when you do that, you end up with 179.6, or in terms of pi, we would be at, well, it's not going to be pretty, so I would just probably leave it like that. I end up with a decimal when I do that. So we'll just leave it right there, and that would be meters cubed. All right, so for number 2, it says the radius of sphere A is 2 inches, the radius of sphere B is 4 inches. How many times larger is the volume of B compared to the volume of A? So if I were you, I would find the volume of sphere A and then the volume of sphere B, and you're going to do some comparison of those two. And you're going to see maybe how much you had to multiply one of them by in order to get to the other one. It should wash itself out pretty easily. So go ahead and try those. And then let me see if there's anything else. We also have a composite figure down here on number 4 where we have a cone sitting on top of a sphere. So remember, actually this is a hemisphere. So be careful. You'll need to determine the volume of the whole thing and then half it in order to determine what's going on there. All right, so go ahead and work through the problems relating to the spheres and the pyramids and cones. And then check your work when you're finished. And if you have any problems, just raise your hand. We'll be glad to help you.